Hello everyone, welcome to the week 8 project of Advanced Structural Mechanics that is on traction and area. A quick overview of what I'll be discussing in this project. First, I'll go through my 3D body and its parameterization. Then I'll be defining a symmetric Cauchy stress on my body. And then I'll be computing traction using Cauchy stress traction relationship on one of the surfaces. And then I'll compute the area using MATLAB and then verify by hand. The body I've chosen is an I section, and here is the parameterization of the I section. So in this case, we are assuming the body to be the basic parameterization of the body to be in the as of the deformed shape of my body. So the deformation gradient would be identity matrix. Here is the Cauchy stress tensor field I've chosen for my body, and here's the corresponding stress field acting on the body. Coding in MATLAB in such way I get the areas as shown, and one of the surface I've chosen is the surface 4, and the areas are 83 in positive E1 direction, 247.5 in positive E2 direction, and 325.5 units in positive E3 direction. Now I'll compute these areas using hand calculations and verify if I'm getting the same areas or not. So the surface is I've chosen is this one, and so the limits would be 0 to L, varying in positive E3 direction. In the positive E1 direction, it would be varying d by 2 minus tf till d by 2, and in the E2 direction, it would be just plus bf by 2. So here are the limits. Now to compute traction, we'll use the Cauchy stress traction relationship, which is given by Cauchy stress dot product with the normal vector to the surface will give us the traction. So in this case, the Cauchy stress is as shown, and the normal vector would be in positive E2 direction. That would be 0, 1, 0, and taking dot product, I guess this as the traction. Now integrating this over the area of this surface would give me the forces acting on that surface. So doing that and applying the appropriate limits, I get area as 83, 247.5 and 325.5, which are the same as computed from MATLAB. I'll quickly run my code. So here's the stress field, and here's the command window, and this is the surface I've chosen, the surface 4, and we can see we have got the same forces as that we received from hand calculation. Thank you.